Welcome to EDU World Space.
Hello, welcome to this lesson. In this lesson, we'll evaluate this integral. So we'll split the integral into three parts. We have the first from integral from 0 to 1 over t plus 1 I dt, then plus integral from 0 to 1 of t squared plus 1. This is the j. We have dt, and the last part, integral from 0 to 1 of t over t squared plus 1 k dt. So let's solve them one after the other. First one, we have integral from 0 to 1 of 1 over t plus 1. This is I dt, right? So this is the length of t plus 1, the absolute value of that I. All right, let me bring the evaluation first. We evaluated from 0 to 1 I. All right, so here we have lane absolute value of 1 plus 1 minus lane absolute value of 0 plus 1, evaluated from we are done with the evaluation, so we'll put the I there, and this becomes lane 2 I. This is because lane 1 is 0. All right, then we have the next part. This is the length for the integral from 0 to 1 of 1 over t plus 1 I dt. Now let's look at the next part, which is integral from 0 to 1 of 1 over t squared plus 1 j dt. So we'll make substitution t, which is equals to tan theta, right? That's what we have dt, which is equals to sec square theta d theta. All right. And now if we put them in without the boundaries, which later we can introduce the boundaries. All right. So here we have integral 1 over t squared plus 1 j dt, which is equals to integral 1 over. Now this becomes tan squared theta plus 1, which is equals to the sec theta, then times dt, which would be sec square theta d theta. All right. So here we have integral sec square theta d theta all over sec squared theta. All right. Because we have tan squared theta plus 1, which is equal to sec squared theta. And this, if this crosses out, that we would have theta. All right. And if you now have integral from 0 to 1, that is, if we introduce back the boundaries, that's t squared plus 1 j dt, then this becomes, here if we have t equals to tan theta, then it would imply that theta is equals to the arctan or the tan inverse of t. All right, so here we have the arctan or tan inverse of t evaluated from 0 to 1. All right, so here we have tan inverse of 1, which is pi on 4, then minus tan inverse of 0, which is 0. All right, so we are left with pi on 4 for this part. So we have evaluated the first one, which gave us the length 2I, and this time we would have, let me not forget the j. So we have pi on 4j. Now we are left with the last part. So this is the last part. Now we're going to make substitution. We will let u be equals to t squared plus 1. All right. So this would imply that the u is equals to 2t dt. All right. And now we can write du over 2, which is t dt. So already have t dt there. So we have integral t over t squared plus 1 k dt, which is equals to integral du. So let me bring the half out, and we will now have u. All right. Then this would be half lane absolute value of u. Okay. So if we now introduce the boundaries, you would have half, then lane, instead of the u will put the t squared plus 1 there, and this we're evaluating from 0 to 1, and this is the k component, so this is half. Lane, if we put 1 there, we have 1 squared plus 1, then minus lane, here we have 0 squared plus 1, and that's k. So we have half lane, this becomes 2k, which we can write as lane square root of 2k. All right. So the whole of the integral, so the whole of this is equals to lane 2i then plus pi on 4j, then plus the last one which we had as lane square root of 2k. All right. So thanks for your time. This is the end of the lesson.